Right now, you are probably looking at a screen. If your vision is not perfect, you are doing it through a curved piece of glass sitting on your face. We carry supercomputers in our pockets. We land rockets backwards on floating platforms in the ocean. Yet, half the global population still relies on a physical technology that was invented in Italy over 700 years ago. Glasses are fragile. Contacts dry out your eyes. LASIK burns away tissue and does not always last. For decades, fixing human vision has been stuck. We just kept polishing the same pieces of glass. But a research lab in China just broke that cycle. Engineers have built a working bionic device that eliminates the glass entirely. It is an artificial retina made of high-density, light-sensitive nanowires. It does not just sit on your eye to bend light. It is designed to physically mimic the biological structure of a human eye, catching light and converting it into electrical signals faster than your own biological nerves. If you are enjoying videos like this, please hit the like button because it takes a lot of effort to make these, and subscribe so you do not miss the next one. This is not a science fiction concept. It is a real physical prototype. It is a solid-state device that could eventually cure specific types of blindness. But fixing medical blindness is only the first step of this project. The real goal is to replace the digital screen you are looking at right now. Chinese engineers are building the foundation to beam digital information directly into the human optic nerve. That changes the entire global technology race. If you do not need a physical screen, you do not need a smartphone. And that puts trillion-dollar American tech companies in the crosshairs. Apple and Meta are currently fighting a massive war. The battlefield is your face. Silicon Valley is obsessed with spatial computing. Apple released the Vision Pro. It costs thousands of dollars. Meta is burning billions of dollars every year on its Quest division. These American tech giants want you to strap a heavy computer to your head. They are betting their entire future on the idea that virtual reality goggles will eventually replace the iPhone. But what if they are building the wrong hardware? While American companies try to shrink a laptop into a pair of ski goggles, Chinese engineers are taking a completely different path. They are bypassing the heavy headset. They are bypassing the glass screen entirely. They are going straight into the human eye. Think of it like the shift from physical mail to email. Why build a faster delivery truck when you can just send the information instantly? Why build a lighter glass screen when you can beam data directly into the optic nerve? This is a direct threat to the American tech industry. The trillion-dollar empires of Apple and Google rely on you holding a physical object. They sell you the glass. They sell you the screen. If a Chinese firm patents a bionic eye that overlays digital maps, text messages, and video right onto your natural vision, those heavy American headsets instantly become expensive paperweights. The hardware war is moving inside the human body. But putting electronics into the human eye is notoriously difficult. The eye is a delicate, wet, biological machine. It fights back against foreign objects. To understand why bypassing the physical screen is so incredibly hard, we first have to look at why our current eye technology has been stuck in the past for centuries. Look at a pair of prescription glasses. It is just a curved piece of plastic or glass. It works by bending light before it hits your eye. That is it. Even the most advanced eye surgery in the United States right now, like LASIK, is essentially just a mechanical fix. A laser burns away a tiny layer of your cornea to change its shape. It is a biological sculpting job. Both of these methods share a massive flaw. They only fix the surface. Think of your eye like a digital camera. Glasses and LASIK fix a scratched outer lens. But if the actual digital sensor inside the camera is broken, fixing the outer lens does absolutely nothing. Inside your eye, that sensor is called the retina. Millions of tiny biological photoreceptors catch light and send it directly to your brain. As you age, or if you have certain diseases, those sensors die. They stop working. No amount of curved glass can fix a dead biological sensor. Once the retina fails, human biology hits a hard physical limit. Medical companies in America spend billions of dollars every year trying to slow down that decay with special drops and complex surgeries. But you cannot naturally regrow a dead retina. The human body simply refuses to fix its own internal hardware. We have accepted this natural failure for centuries. We just buy thicker glasses and hope for the best. This hard physical limit is exactly what Chinese engineers decided to ignore. The human retina is a biological masterpiece. It is shaped like a curved dome. That physical curve is exactly why humans have such a wide, natural field of view. For years, scientists tried to build artificial eyes using flat electronic sensors. Think of the digital microchip sitting inside an iPhone camera. It is completely flat. When you put a flat sensor inside a curved eye cavity, the image distorts. The light simply does not focus right. A team of researchers from Hong Kong and mainland China finally solved the curvature problem. They built a device called the ECI, which stands for electrochemical eye. They did not use normal flat silicon chips. Instead, they built a curved membrane out of aluminum oxide. Then, they packed that artificial dome with millions of tiny, light-sensitive nanowires. To understand a nanowire, think of a microscopic solar panel shaped like a single strand of hair. When light hits the wire, it immediately generates a tiny electrical charge. The Chinese team packed these nanowires together incredibly tightly. They achieved a sensor density even higher than the biological photoreceptors inside a natural human eye. This is where the engineering gets fascinating. A natural human eye takes about 40 to 150 milliseconds to react to a sudden change in light. The nanowires in the Chinese prototype react in just 19 milliseconds. The artificial eye actually processes light faster than a biological human brain can. In the United States, patients often wait years for slow-moving pharmaceutical trials just to get access to basic new eye drops. Meanwhile, labs across the Pacific are printing synthetic retinas that outpace human biology. The researchers connected these synthetic nanowires to liquid metal wires. These liquid wires act exactly like a human optic nerve. The device successfully transmitted visual signals directly to a computer. The machine saw the world. But mimicking human biology was only step one of the project. A synthetic eye that just copies human vision is a massive medical breakthrough. But it does not threaten the tech industry. Step two was pushing the hardware past natural biological limits. Human biology has a strict limit. We only see a very tiny slice of the light spectrum. We cannot see radio waves. We cannot see thermal heat. We are completely blind in the dark. If an American soldier or a police officer wants to see heat signatures at night, they have to strap heavy, expensive night vision goggles to their helmets. The Chinese nanowire eye does not have this biological restriction. Because the nanowires are entirely synthetic, engineers can tune them to pick up light frequencies that natural human eyes simply cannot process. By adjusting the chemical materials inside the tiny wires, the artificial retina can detect infrared light. Think about what that actually means. A person with this bionic implant would not just have their normal vision restored. They would have built-in night vision. They could walk into a pitch-black room and clearly see the heat radiating off a warm cup of coffee or a person standing in the corner. American tech companies sell smart security cameras for hundreds of dollars just to give you a grainy thermal feed on your phone. This device puts that exact hardware capability directly inside the human skull. It makes the medical term 20/20 vision completely irrelevant. 20/20 is the absolute ceiling for biological human vision. For a bionic eye, 20/20 is just the lowest baseline setting. You are upgrading the human body the exact same way you upgrade the software on a Tesla. The physical limits of the eye are being stripped away by material science. But giving a human built-in night vision is just a physical hardware trick. If you can stream an infrared signal directly into a synthetic optic nerve, you can stream absolutely anything to it. Right now, you hold an iPhone in your hand to read a text message. If you want to use Apple's Vision Pro, you strap a heavy computer to your face. Both of these rely on a physical piece of glass. But if an artificial retina can capture light and send it to your biological nerves, the system can process digital inputs too. You bypass the physical world entirely. Chinese engineers are building the framework for an invisible screen. The bionic eye can act as a direct receiver for digital data. Imagine walking down a busy street in New York or Chicago. Instead of looking down at Google Maps on your phone, the directions are painted directly into your natural field of view. A glowing arrow floats on the pavement. A text message from your boss appears quietly in the corner of your vision. You do not need an external display. The retina itself becomes the display. This is a massive threat to the core business model of American tech companies. Apple makes its billions by selling you a glass screen. Samsung sells you a glass screen. The entire U.S. consumer electronics market is built on manufacturing and selling physical displays. If a bionic lens projects data straight into your optic nerve, the smartphone is dead. The desktop monitor is dead. The smartwatch becomes a useless piece of jewelry. You eliminate the middleman completely. Why would an American consumer spend thousands of dollars on a bulky virtual reality headset when a tiny implant does the exact same thing invisibly? The company that controls this technology controls the future of human communication. But putting a computer inside the human eye creates a massive physical problem. A computer requires electricity. It needs constant power. And that was the biggest engineering bottleneck. If you want to put a computer inside a human body, you run into a brutal physical problem. Electronics need power. Power creates heat. Think about your smartphone. When you use it heavily, the back gets hot. Now, imagine that same heat pressing directly against the wet, delicate tissue of your eyeball. It would cook your optic nerve. You cannot just put a standard lithium-ion battery inside a human eye. It is like dropping a car battery into a bowl of salt water. It shorts out. It causes permanent damage. For years, American medical companies struggled with this exact hurdle. If you have an implant, how do you charge it without burning the patient? Imagine having to plug a charging cable into your own face every night. The Chinese Nanowire prototype tackles this through sheer material efficiency. The nanowires act like microscopic solar panels. They generate their own tiny electrical charges just by absorbing ambient light. But future, fully digital versions require wireless power transfer. Researchers are developing ultra-thin coils that harvest energy from the environment. They use solid-state transfer. It beams power seamlessly to the implant, just like a wireless charging pad powers a phone. But this happens across a gap of human tissue without generating dangerous heat. The eye effectively becomes a self-sustaining machine. No external battery packs. No wires running down your neck. The device pulls the tiny amount of energy it needs invisibly. Think about an Apple Vision Pro. It forces you to carry a heavy battery pack in your pocket with a cord running up your back. This implant solves that physical hardware trap entirely. With the hardware finally solved, a much darker question emerges. When a device is connected to a network, data flows in two directions. If an artificial eye can stream a digital map to your optic nerve, it can also send information back to a server. Right now, American tech companies like Meta and Google track what you click on. They track how long you watch a video on your phone. That is how they sell targeted ads to US consumers. But a bionic eye tracks the physical movement of your eyeball. It knows exactly what you look at in the real world. It knows exactly how long you stare at a physical product on a store shelf. It monitors your pupils. When your pupils dilate, it means you are excited or interested. Think about what this means for personal privacy. A connected retina is the ultimate tracking machine. It removes the guesswork entirely. It knows your emotional reaction to an advertisement before you even realize you want the product. If a foreign tech company controls the hardware in your eye, they control the most private data you can possibly generate. They see the world exactly as you see it. They know who you look at in a crowded room. In the United States, lawmakers worry about smartphone apps tracking our keystrokes. But keystrokes are just conscious physical actions. A bionic eye tracks raw human attention in real time. It is a direct, unfiltered feed of human consciousness. There is no phone to put down. There is no screen to turn off. You cannot leave your eye on the kitchen counter. The data collection becomes a permanent, invisible part of your biology. This level of absolute tracking completely erases the old rules of consumer privacy. And this exact capability is why military strategists and government agencies are paying very close attention. War is decided by a very simple rule. The side that sees the enemy first usually wins. Right now, the United States military spends billions of dollars to give its soldiers an edge. Think about the helmet worn by an American F-35 fighter pilot. It is an incredible piece of engineering. It projects radar data, altitude, and targeting information directly onto a glass visor. But that helmet is bulky. It is heavy. It relies on external sensors and fragile glass. Now, imagine an infantry soldier with a bionic retina. They do not need a heavy helmet. The tactical data is beamed directly into their optic nerve. As they walk through a dark city street, their vision naturally shifts to thermal imaging. They see the heat signatures of enemy troops hiding behind a concrete wall. They look up at the sky, and a live video feed from an overhead drone plays in the corner of their natural vision. This offers a massive tactical advantage. If a rival nation equips its special forces with biological supersight, the rules of ground combat change entirely. A sniper could digitally zoom in on a target without a physical scope. A soldier could track friendly troop movements as glowing markers overlaid on the real world. The human body essentially becomes a fully integrated weapons platform. American military dominance relies heavily on superior external hardware. But if the hardware is surgically implanted into the human eye, the gap closes instantly. You cannot shoot a helmet off a soldier if the display is wired into their brain. This technology turns a regular human into a digital node on the battlefield. Despite these massive geopolitical implications, you cannot just walk into a pharmacy and buy this tomorrow. It is easy to look at a working prototype in a Chinese lab and assume it will be on store shelves next year. That is not how medical hardware works. Building one perfect synthetic eye for a research paper is a massive engineering triumph. Mass-producing millions of them in a commercial factory is an absolute manufacturing nightmare. The nanowires inside this device are microscopic. If a robotic arm on an assembly line makes a mistake by a fraction of a single millimeter, the entire artificial retina is ruined. Right now, there is no commercial factory on Earth capable of manufacturing these advanced devices quickly and cheaply. It is like trying to build a modern car engine using only surgical tweezers. Then you hit the biological wall. The human immune system is specifically designed to attack foreign objects. If you wire a synthetic dome into a wet, biological optic nerve, the body immediately tries to reject it. Scar tissue builds up around the wires. The electrical connection fails. Material scientists still have to figure out how to chemically trick the human body into accepting this hardware permanently. Finally, there is the United States government. If this technology ever wants to reach American consumers, it has to survive the FDA. That means years of strict, expensive clinical trials. Regulators want to know exactly what happens if the power system fails. They want to know if the synthetic materials degrade inside a human skull after a decade of use. That bureaucratic process alone can delay a commercial launch by 10 years. The gap between a brilliant lab experiment in Asia and a finished product you can buy at an American hospital is huge. But even with these massive physical hurdles, the countdown has started. We are living in a very specific window of human history. Decades from now, people will look back at us and find it strange. They will wonder why we accepted failing eyesight as a normal part of getting older. Right now, if an American loses their vision to disease or age, they simply buy thicker glasses, get a walking cane, or learn Braille. We treat biological decay as a permanent rule of life. But the Chinese nanowire prototype proves that this rule is actually just a mechanical problem. And mechanical problems eventually get solved. The companies that control this solution will control the next era of human interaction. American tech giants are currently betting their billions on heavy headsets and external glass screens. But the real finish line is not a better screen. The finish line is erasing the screen entirely and merging the hardware directly with the human body. Think about how we replace the horse with the combustion engine. We are about to do the exact same thing with human biology. We are moving from natural limits to synthetic upgrades. The artificial retina is just the beginning. It starts as a medical cure for the blind. Then, it becomes a tactical tool for the military. Finally, it becomes a consumer product that makes the smartphone completely obsolete. We are the last generation to view the human body as a finished product. From here on out, human biology is just another piece of hardware waiting for an upgrade. When that happens, the companies that control the implants will control how we see reality itself. They will dictate what is real and what is digital. So, look at the screen in your hand right now. It might be one of the last external devices you ever buy,